From the previous video, we have learned all about signal generation and modulation, its different forms, methods, and techniques. Suppose that you already have produced a modulated signal and are already able to transmit it through an antenna. What do you do now? We are talking about communications here. And just like when you are talking, where you need someone to listen to whatever you're saying, there also needs something to receive the modulated signal we have generated and transmitted. This is where radio receivers and AM demodulation come into application. AM demodulation is the reverse process of AM modulation. A conventional double-sided band AM receiver simply converts a received amplitude modulated wave back to the origin source information. One excellent example is sending messages through your favorite messaging app. The process is that you type your message and click send. When you click the send button, your phone does its job by translating it into a radio signal, which is to be received by whoever you are texting. When his or her phone receives a radio signal, it again does its job. It will convert that radio signal back to its original form, which is in text format. In that case, what you send is what your friend received. Thus, the communication process is successful. To do this, a receiver must be capable of receiving, amplifying, and modulating. An AM wave, it must be capable of band limiting the total radio frequency spectrum to a specific desired band of frequencies. The selection process is called tuning the receiver. To completely understand the demodulation process, first it is necessary to have a basic understanding of terminology commonly used to describe radio receivers and This is simplified block diagram of a typical AM receiver. The RF section is the first stage of the receiver and is therefore often called the receiver front end. The primary functions of the RF sections are detecting, band limiting, and amplifying the received RF signals. The mixer or converter section is the next stage. This section converts the received RF frequencies to intermediate frequencies, which are simply frequencies that fall somewhere between the RF and information frequencies, hence the name intermediate. The primary functions of the IF sections are amplification and selectivity. The AM detector demodulates the AM wave and converts it to the original information signal. And the audio section simply simplifies the recovered information. These are the basic functions of a receiver. The receiver should be capable of changing the range of frequencies to be received. Frequency selection is the discrimination of the part of the radio frequency spectrum that contains the desired information from the entire spectrum of electromagnetic oscillations acting on the antenna. There are lots of radio signals present in the entire frequency spectrum. Thus, it is necessary for a receiver to be able to discriminate certain frequencies and pick specific range in order to receive the proper information. Second, the receiver should be able to detect and convert the received RF signal to the original source information. Detection is the conversion of modulated radio frequency oscillations to electric oscillations corresponding to the modulation envelope that directly convey the transmitted information. Third, the receiver should be able to provide sufficient amplification. Amplification is the magnification of the energy of the received oscillation, which are usually very weak to a usable level. There are several parameters commonly used to evaluate the ability of a receiver to successfully demodulate a radio signal. The most important parameters are selectivity and sensitivity, which are often used to compare the quality of one radio receiver to another.